The universe could end right now. Not tomorrow, not in a billion years, right now. This second, while you're watching this video, and you wouldn't even see it coming. We tend to think the universe is stable, right? The laws of physics are fixed. Atoms hold together. Stars burn. Planets orbit. Everything follows predictable rules that have worked for 13.8 billion years. But what if all of that is temporary? What if the universe we live in is actually unstable, like a house of cards balanced on the edge of a table, waiting for the smallest breeze to knock it over? There's a scenario in physics called false vacuum decay, and it's one of the most terrifying ideas in all of science, because if it's real, and a lot of physicists think it might be, then the entire universe could spontaneously collapse into a different state at any moment. No warning, no escape, no defense. The challenge isn't just understanding this scenario. The challenge is accepting that we have no way to know if we're safe. We could be living in a false vacuum right now, and the collapse could happen at any second. Here's the core problem with our universe. We assume it's in its most stable state, that the fundamental forces, gravity, electromagnetism, the strong and weak nuclear forces, are set to their final permanent values, that atoms and molecules and chemistry work the way they do because that's just how reality is. But quantum physics says something disturbing. It says that what looks stable might not actually be stable. It might just be metastable, meaning it looks like it's in the lowest energy state, but there's actually a lower state it could fall into. Like a ball sitting in a shallow dip on a hillside. It looks settled, but if something nudges it just right, it could roll down to an even lower point. And if our universe is in a metastable state, what physicists call a false vacuum, then at any moment, anywhere in space, a random quantum fluctuation could cause it to transition to the true vacuum, the real lowest energy state. When that happens, a bubble forms. Inside the bubble, the laws of physics are different. Atoms can't exist. Chemistry doesn't work. Matter as we know it just falls apart, and the bubble expands at the speed of light, consuming everything in its path. No warning, no escape, no defense. The challenge isn't just understanding this scenario. The challenge is accepting that we have no way to know if we're safe. We could be living in a false vacuum right now, and the collapse could happen at any second. Let's start with the basics. What do we even mean by the vacuum? When most people think of a vacuum, they think of empty space, nothing there, just void. But in quantum physics, the vacuum is anything but empty. It's filled with quantum fields that permeate all of space. There's an electromagnetic field, a quark field, a Higgs field. Each of these fields has a certain energy level even when nothing is happening, and that energy level determines how the universe behaves. Think of it like this. Imagine a landscape with hills and valleys. The fields in our universe naturally want to settle in the lowest valley, the state with the least energy. That lowest point is called the true vacuum. But here's the problem. What if the fields didn't actually settle in the lowest valley? What if they settled in a higher valley that just looks like the lowest point from where they are? That would be a false vacuum. It's stable enough that the fields stay there, but it's not the true minimum. And if something gives them a push, a quantum fluctuation, a random event, they could suddenly drop to the real minimum. And when that happens, everything changes. The reason physicists take this seriously is because of the Higgs field. You've probably heard of the Higgs Boson. It was discovered in 2012 at the Large Hadron Collider. The Higgs boson is an excitation of the Higgs field, the field that gives particles their mass. But here's the thing. When scientists measured the mass of the Higgs boson, they got a number that was concerning, because based on that mass and the mass of the top quark, they could calculate whether the Higgs field is sitting in a true vacuum or a false vacuum. And the answer? It's right on the edge. Maybe stable, maybe metastable. The calculations are so close that small uncertainties in the measurements could tip it either way. Some physicists think we're fine, the universe is stable and will stay that way forever. Others think we're in a false vacuum and the collapse could happen at any time. And the really unsettling part? There's no experiment we can do to be sure. We can't test the stability of the entire universe. We can only calculate and hope the math is right. Okay, so let's say we are in a false vacuum. How would the collapse actually start? It would begin with a quantum fluctuation. At the quantum level, things are constantly popping in and out of existence. Virtual particles appear and disappear. Fields fluctuate randomly. Most of the time, these fluctuations are tiny and don't do anything. But every once in a while, purely by chance, a fluctuation could be big enough to push the Higgs field over the edge, to nudge it out of the false vacuum and into the true vacuum. And when that happens, a bubble forms, a tiny region of space where the field has dropped to its true minimum. And inside that bubble, the laws of physics are different. The thing is, the true vacuum has lower energy than the false vacuum, so the bubble is more stable than the space around it, and because of that, it starts to grow. The boundary between the true vacuum and the false vacuum expands outward at the speed of light, and as the bubble expands, it destroys everything it touches. Let's talk about what it would be like inside a false vacuum decay bubble. The first thing to understand is that the fundamental constants of nature would be different. The strength of the electromagnetic force could change. The masses of particles could change. The way quarks interact could change. And when you change those constants, chemistry stops working. Atoms can't hold together. Electrons might not bind to nuclei anymore. Protons might decay. The entire structure of matter would collapse. Imagine you're standing on Earth, going about your day, and then the bubble reaches you. You don't see it coming. It's moving at the speed of light, so there's no warning. The first indication would be the moment it arrives. And then, instantly, the atoms that make up your body stop being atoms. They fall apart into their constituent particles, but even those particles might not exist anymore because the forces that define them have changed. You don't die, you don't disintegrate, you just cease to exist in any meaningful way, because the physics that allows you to exist no longer applies. Stars would go out, planets would dissolve, galaxies would vanish, and all of it would happen faster than light could carry the information to warn anyone. Here's the part that makes this scenario so uniquely terrifying. The bubble expands at the speed of light. Not slower, exactly at the speed of light. And because nothing can travel faster than light, there's no outrunning it, there's no escaping it. If the bubble is coming toward you, you will never know until it's already here. Think about that for a second. Right now, a false vacuum decay bubble could have started 1 billion years ago in a distant galaxy. It could be expanding toward us at light speed, consuming everything in its path, stars, planets, entire civilizations, and all of it would happen faster than light could carry the information to warn anyone. You could point the most powerful telescope in the universe at the sky, and you'd see galaxies shining normally, stars burning, planets orbiting, everything looking fine. But some of those galaxies might already be gone, erased by a bubble that's still racing toward us, invisible and unstoppable. The universe could be half destroyed, and we'd never know until the bubble reached us. This is the question that keeps cosmologists up at night. Has false vacuum decay already happened somewhere in the universe? The answer is, we have no idea, and we can't know, because if it has happened, the bubble could be anywhere. It could be a billion light years away, slowly eating its way through the cosmos. It could be 10 light years away. It could be 1 light year away. Or it could be starting right now, this very second. Somewhere in the universe, a quantum fluctuation could be occurring that will eventually lead to the destruction of everything. And there's nothing we can do about it. We can't stop it. We can't detect it. We can't prepare for it. Some physicists have tried to calculate the likelihood of false vacuum decay happening. The numbers they get are not comforting. The universe is huge and old. There have been trillions upon trillions of quantum fluctuations over 13.8 billion years. The fact that it hasn't happened yet might just mean we've been lucky. Or it has happened, and the bubble just hasn't reached us yet. There's no way to know. Let's compare this to other ways the universe could end. Heat death. Eventually, in trillions of years, the universe will expand so much that all the stars will burn out and everything will reach the same cold temperature. That's sad, but it's predictable. We know it's coming. Big Rip. If dark energy gets stronger over time, it could eventually tear apart galaxies, then stars, then planets, then atoms. Again, terrifying, but it would take billions of years and we'd see it happening. Black holes. They could destroy planets and stars, but they're localized. We can track them. We can avoid them. But false vacuum decay? It's instant. It's invisible. It's unstoppable. And it could happen at any moment with zero warning. You can't prepare for it. You can't build a bunker deep enough. You can't escape to another planet or another galaxy, because the bubble would eventually consume all of space. It's the ultimate cosmic lottery, except instead of winning, you just stop existing. And the ticket is drawn every single moment of every single day across the entire universe. Here's what really gets me about this. If false vacuum decay is real, then everything is temporary. Not just in the sense that stars die and planets get destroyed. I mean temporary in the most fundamental sense. The laws of physics that have governed the universe for 13.8 billion years could just stop. The rules that allow atoms to exist, that allow chemistry and biology and consciousness, all of it could be erased in an instant. Every civilization that has ever existed, every thought that has ever been thought, every piece of art, music, literature, science, all of it could be wiped out before anyone even realizes what's happening. And here's the kicker. If it happens, there's no coming back, no reboot, no second chance. The universe doesn't reset to a previous state. It just becomes something else, something where life as we know it cannot exist. It's the ultimate cosmic nihilism, the idea that everything is fleeting, that nothing is guaranteed, that the universe itself is fragile and could shatter at any moment. But here's the thing, we're still here, 13.8 billion years into the universe's history, and the vacuum hasn't decayed yet. That's either really good luck or the universe is more stable than we think. Here's the moment that really puts this in perspective. Imagine the universe is a vast ocean, and somewhere deep underwater, a bubble forms, a tiny bubble of true vacuum expanding at the speed of light in all directions. On the surface, everything looks calm. Stars are shining, galaxies are spinning, life is thriving on billions of planets. Nobody knows the bubble exists, but it's growing, consuming stars, erasing galaxies, rewriting the laws of physics as it spreads. And one day, maybe a billion years from now, maybe tomorrow, the bubble reaches Earth. You're going about your day, drinking coffee, scrolling through videos, completely unaware. And then, in an instant that you don't even have time to perceive, the bubble arrives. The fundamental constants of nature shift. The atoms in your body can't hold together anymore. The chemistry that powers your brain stops working. and you're gone. Not dead, just gone, erased from existence along with everything else in the bubble. And the bubble keeps expanding, consuming the sun, the planets, the Milky Way, Andromeda, every galaxy in the universe, one by one, swallowed by a wave of destruction that nobody can see and nobody can stop. Until finally, the entire universe is in the true vacuum. Different physics, different rules, no stars, no planets, no life. Just an empty, dead cosmos where the universe we knew is nothing but a memory. Except there's no one left to remember. That's false vacuum decay, the ultimate end. Not with a bang or a whimper, just with silence. Let's bring it all together. Our universe might be in a false vacuum, a metastable state that looks stable but isn't actually at the lowest possible energy level. If that's true, a quantum fluctuation could cause the vacuum to collapse into the true vacuum at any moment. When that happens, a bubble forms and expands at the speed of light in all directions. Inside the bubble, the laws of physics are different. Atoms can't exist. Chemistry doesn't work. Everything we know just falls apart. The bubble is invisible. It travels at light speed, so there's no warning. The first sign of it would be the moment it arrives, and by then, it's already over. We don't know if we're in a false vacuum or a true vacuum. The calculations are too close to call. We don't know if a bubble has already formed somewhere in the universe and is racing towards us. We can't detect it. We can't stop it. We can't prepare for it. All we can do is hope that either the universe is stable or that we're lucky enough to live in a time and place where the bubble hasn't reached us yet. False vacuum decay is the ultimate cosmic threat, not because it's likely, but because it's possible, and because if it happens, there's nothing we can do. The universe could end right now, this second, and the scary thing? We wouldn't even know. So maybe that makes every moment we have more precious, more urgent, more real, because none of it is guaranteed. Not the sun rising tomorrow, not the atoms holding together, not even the laws of physics themselves. We're living on borrowed time in a universe that could collapse without warning. And maybe, just maybe, that's what makes it all matter.